So problem 7.3.8 actually reaches back to Unit 4 when we discussed empirical formulas. So the first thing we have to do is use the ideal gas law to determine the number of moles of this gas that we have. And then we can determine the molar mass and the empirical formula of it, and the molecular formula of it. So if I have 0.157 grams of this substance, and the volume is going to be 125 milliliters, which will be 0.125 liters. The pressure is 99.5 kilopascals, which we will have to convert to ATM, and a temperature of 22 degrees Celsius, which we will have to convert to Kelvin. The ATM is going to be approximately 0.982. We divide by 101.3, and the temperature in Kelvin, we add 273, and it will be 295. So using the ideal gas law, pressure 0.982, ATM times volume 0.125 liters is going to be equal to some number of moles times the gas constant, liters, ATM, moles, Kelvin, times 295 Kelvin, and the number of moles of gas that we will come up with should be 0.005071. We can then take those moles and divide it into the number of grams we have to get that the molar mass of the substance should be 30.96 grams per mole. So now we can reach back into our empirical formula method, and if we have 39% carbon, that's the same if we had 100 grams of it, of having 39 grams of carbon. Convert that to moles and get 3.25 moles of carbon. If we have 45% nitrogen, that's the same as having 45 grams in a 100 gram sample. So we convert that to moles of nitrogen, and we get approximately 3.21 moles of nitrogen. And then finally for hydrogen, 16%, if we have 100 grams of it, is the same as having 16 grams. So that's 1 mole divided by 1 gram, so we're going to have 16 moles of hydrogen. My smallest ratio is N, so I'm going to divide that into the others. And what I'm going to find is that I have 1 C for every 1 N for every 5 H's. So overall, my formula should be CnH5, or some variation of that. And if you add up these elements from the periodic table, you find that the molar mass is 30.96. So the empirical formula in this case is the molecular formula, and the answer is CnH5, or some variation of those letters in that order.